The physics behind the bubble cascade that forms in a glass of Guinness beer. Air pocket texture of Guinness beer in pint glass. Air pocket surface of Guinness brew in a 16 ounces glass, highlighting the smooth taste of minuscule air pockets and entrancing surface movement. Credit: Osaka University. Does bubble course frame just in a glass of Guinness lager? Analysts from Osaka University and Kirin HD clarify the physical science that supports falling progression of nitrogenated bold lager, with applications to water refinement and drug creation. As far back as 1959, brewers at Guinness fostered a framework that essentially modified the surface of their draft lager. Presently, analysts from Japan have settled the physical science of Guinness falling stream, which will have boundless applications to innovation throughout everyday life and ecological sciences. In an examination as of late distributed in Physical Review E, scientists from Osaka University have uncovered why the nitrogen air pockets of Guinness draft brew stream comparatively to a liquid. The air pockets of some open carbonated refreshments basically move upwards, following Archimedes' standard. A significant part of the allure of the draft from Guinness lager is that the air pockets sink and stream aggregately, known as bubble course. Brewers and specialists accept this aggregate stream conduct should have something to do with how draft Guinness brew is administered. As of now, the material science of the aggregate stream stays unsettled, something the analysts at Osaka University plan to address. Air pocket motion trapezium glass. Air pocket movement in a trapezium glass. Each drink, from left to directly in each board, Guinness lager, Heineken brew, champagne, Coke, carbonated water, was filled a trapezium glass. Credit: Osaka University. A wide scope of lab work and computational reenactments has been helpful for assessing individual and aggregate air pocket movement, however solely after the stream has happened, says lead and senior creator of the investigation Tomoaki Watamura, Osaka University. We're keen on foreseeing falling stream by means of numerical demonstrating, as opposed to results from investigations or reenactments afterward. To do this, the specialists utilized mathematical reproductions to rough the liquid and air pocket particles of falling draft lager. Seat work tests comprised of testing a straightforward, pseudo-Guinness liquid, which is a combination of tiny empty particles in faucet water, and genuine Guinness lager. Molecule concentration distribution. A. Configuration and preview of molecule focus conveyance. B. Comparison of the circulation of mimicked particles, left, and Guinness brew bubbles, right, at the midpoint. C. Snapshots of an air pocket focus wave framing in a 16 ounces glass, upper left, a mixed drink glass, top focus, and a 1 Oz, 30 ml, shot glass, upper right. Stage graphs of scaled speed variance, base. The concealed regions compared to the ordinary elements of the glasses. Credit: Osaka University. The reproduction results coordinated with exploratory information, over a wide scope of glass sizes and different conditions, clarifies Watamura. We have fostered the best reenactment of falling stream in Guinness brew to date. Intriguingly, falling air pockets may not need a nitrogenated heavy lager, all things considered. The air pocket distance across and bubble volume portion in carbonated water filled the surmised measurements of a typical 200-liter drum with tendency point. Work with falling air pockets, says Hideyuki Wakabayashi, Kirin HD. Besides, the related smooth movement, almost a slanted holder divider, relates to support of item quality during preparing, proposing a quick utilization of our discoveries. As well as demonstrating knowledge into advancing preparing conditions, this examination has clear applications to any work that includes fermenters or cell brooding. Thusly, the Osaka University and Kirin HD analysts' discoveries might be utilized to address assorted issues, for example, drug creation from mechanical scale cell societies, and city water cleansing.